let me ask Albino something real quick, because this is all correct. But Pythagorean identities. What's another way you can write tangent squared theta? Secant squared theta minus 1? Which is this, right? So you just went the long way. But the key to this problem is just rewriting tangent squared theta as secant squared theta minus 1. That's it. Once you rewrite tangent squared theta as secant squared theta minus 1, you're done, because the antiderivative of secant squared theta is tangent theta, and the antiderivative of 1 is just theta, and we're finished. This is a good example of a problem that you can make very difficult if you don't realize the identity. But this was also a homework problem, so theoretically you should have run into this. And then therefore this should have been a gimme quiz. But I understand life happens. You don't always get your homework done all, you go up to number 17, or, right? Things happen, right? Okay. Now, the reason why I gave you that problem in particular is because I had another quiz in mind, and it's on your desk now. I've given you 2 documents there in front of you. Make sure you have 1 copy of each. One of them is called the trigonometric integrals and substitutions sheet. This sheet is on Canvas in case you lose it. You are allowed to have this on your next test. You're welcome.
Thank you.
Okay, so this is very helpful, but you need to know how to use it, right? So we'll be using this today. The first parts of these, the things that are written in paragraphs, right? There's 2 like paragraphs there. Those are the 2 basic concepts from last class, in the class before, which is how you integrate sines and cosines, how you integrate tangents and secants. The stuff in the table on the bottom is what we're going to cover today. I started talking about that last class. Okay? Does anyone have any questions before I erase this on how this is done? Anyone not see what you were supposed to do? We're all good? All right, so the quiz that you didn't have to take. Let's take it. Let's do it. Okay, we are continuing now 6.2 or 6.2. We are talking about trigonometric substitutions. Trigonometric substitutions are useful when we see one of 3 things, and this is what's in that table on the bottom. If we see something that looks like ax squared or a squared minus x squared, or we see a squared plus x squared, or we see x squared minus a squared. Depending on which of these we see, we are going to make a substitution, right? Is that clear? In the center, it says what the substitution is going to be. It also gives you some domain restrictions for your theta to make these substitutions. And then it also reminds you on the side which identity will be useful when we make the substitution. So everyone have a copy of the quiz? Yes? All right, so I gave this quiz to my other class. And it's because they got a little further than you did last time. We got bogged down a little bit. We lost about 15 minutes doing some stuff. So they had seen a couple more examples of this, so that's what I gave them. I didn't want to give you that, so we'll do it now. All right, so it is square root x squared minus 25 over x dx. So when we're looking at integrals, we always first want to make sure that we can't do it some easier way, right? Like, can I just do a basic u substitution here? Well, I'd have to see something in its derivative, right? Yeah, if I try and use the x squared minus 25 as u, the derivative of it is 2x, but that's down here, and that's probably not going to work. So after you exhaust the other methods by just thinking through them and realizing, you know what, I've got a square root, I've got an x squared minus a squared. It looks a lot like this one. Then you can start thinking that you're going to probably use that formula, right? And according to the table, you're going to make what substitution?
X is equal to
x is equal to a secant theta. So remember last class I said, like, this is what I'm thinking? I'm like thinking about this is what I'm going to be doing. And for my particular problem, a would be 5, right? We good? So once I have established this, right? Once I've established this, I need to actually write down 3 things. And that's what on the quiz I wanted you to do, like if you had taken that quiz. First thing, write down, fill in that box. This is number 1, part A. Let x equal, so this is you making the actual substitution. X is equal to, for us, what? Yes, a secant theta, which would be 5 secant theta. Make sense? Why is it 5? Because a is 5 for us. This is the general idea of what we're going to do, but for our particular problem, the a is 5. All right, the next thing that you do, once you establish what x is you differentiate it. And so dx should be the derivative of 5 secant theta, which is 5 secant theta tangent theta d theta. That's just differentiation, right? Then the last thing you need to do before you actually rewrite the integral is to figure out what the square root of x squared minus 25 is going to turn out to be. So I think I had, what, 4 boxes there? The first box, you would just replace x with 5 secant theta, so how about 25 secant squared theta, then minus 25. So that's just replacing, that's x squared right there, minus 25. What do you think I wanted in the next box? No, in the next square root down, what do you think I wanted? Factor out of 25. Okay, so the next one, you would take this, factor out of 25. When you do that, you're left with secant squared theta minus 1, right? And yeah, and if you look at this box here, we're doing the bottom substitution, and on the right you have that identity, and it's reminding you that secant squared theta minus 1 is tangent squared theta. So I'm going to use that now to rewrite this as square root, I'm coming up with this here, square root of 25 tangent squared theta, and then the last box there's no root, right? Notice that? So you're actually going to take the square root of this, which is 5 tangent theta. All right, so I'm going to just summarize everything that I've done here. I looked at that integral. I realized, you know what? Somebody told me that when I see that, I should make this substitution. Right? That's what I've told you. Someone told me that. I'm telling you that now. When you see something like this, x squared minus a squared, you should make this substitution. So we've got this. We've got that the derivative of x is 5 secant theta tangent theta d theta. And we have that the root of x squared minus 25 is equal to 5 tangent theta. Those 3 pieces of information will now be used to rewrite the integral in terms of theta. And that would be part 2 there, right? So when I go back and I rewrite this integral, it's going to become integral. Now this part right here is what? 5 tan theta. And then over x, which is 5 secant theta. And what am I missing? The dx here must be replaced. All right, that's where most students forget. They forget the dx has to be replaced also. So dx is 5 secant theta tangent theta d theta. 5 secant theta tangent theta d theta, right? And now you're going to get some nice canceling. This secant theta and the 5 cancel with this secant theta and the 5. Does not always happen like this, all right? But in this particular problem, it did happen. And I have a 5, right? That can come out. Integral of tangent squared theta d theta. And that's what I just gave you as a quiz. right? Except the 5, I didn't give you the 5. So at this point, you would be done with parts 1 and number 1 you'd be done with, sorry. You flip it over to part 2. I did not make my class do part 2. We didn't have enough time. So I gave them 5 minutes this morning to fill out the front page. All right, but we did this, right? So we can continue. This should be 5 integral, and then we know we can split tangent squared theta into secant squared theta minus 1. This was that step that you needed to see on that quiz. From here, integrate these one at a time, right? And bring the 5 along. Antiderivative of secant squared theta is tangent theta. Antiderivative of 1 is theta. And then plus c. So that's where we are. Yeah, but we're not done because we've got everything. We got to get everything back in terms of x. But are we good up to here?
So distribute the 5.
You can distribute the 5. You can leave it. It's really up to you. I'm just going to hold off on it for a second until I write the next line.
Well, that's what I mean. Once you distribute the 5, you can just plug in.
Oh, yeah, I see what you're saying. Yes, I see what you're saying. Because it works out that way, it would be just a replacement. What's being pointed out is that if I distribute the 5 through, this would become 5 tan theta minus 5 theta. Everyone agree? And then you're pointing out here that 5 tan theta, you know what that is, don't you? It's this. And so I could just write that in there. I agree completely 100% with that. But it's not always going to work out that easy. So what's more constructive, which is more meaningful, is to get used to drawing that reference triangle, right? So I'm going to do that for every single one of these problems. Even if I can get the answer right now, just by looking, I'm still going to draw the reference triangle. All right, so I need to know 2 things. I need to know tangent of theta, and multiply times 5, and I need to know what theta is, right? And I need those in terms of x. So does anyone remember from last class what I'm going to go use to draw that reference triangle? Where I go? The original substitution, the one that we started the whole thing off with. That equation right there, you're going to get rid of the 5 on the right side by dividing both sides by 5. So I'm kind of, here comes my reference triangle. I divide both sides by 5. I get secant theta is x over 5. That gives me a relationship between theta and x. I am going to use that relationship to create a right triangle with theta as my reference angle, and then use my knowledge of secant and how it corresponds to, hypotenuse, adjacent, opposite, to kind of draw the sides of the triangle. So which side's what? Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse. So that should be flipped over, right? So that should be hypotenuse over adjacent. So the x should be the hypotenuse, and the 5 should be the adjacent. So I put x here, put 5 here. And do you all remember what that missing side will always be? That square root part that we had. And what was our square root part? X squared minus 25. Which you could also get without remembering that. You could just solve the triangle. Okay. From that, I should be able to get any trig function. Tangent would be opposite over hypotenuse. So this over this. So I should be able to handle that. How about theta by itself? So how am I going to find out what theta is? Yeah, the equation here that has the theta in it right here, secant theta, I take arc secant of both sides. So if I take arc secant of the left side, or inverse secant, however you want to say it, and I take inverse secant of the right side, then the right side's theta, isn't it? And the left side is the arc secant. So I'm replacing theta with arc secant of x over 5. Replacing tangent theta with root x squared minus 25 over 5. And I should be at my answer when I write that down. All right, so this was all kind of like scratch work off the side that I did. And now I'm going to come back and finish this up. So that is 5. Now my tangent, root x squared minus 25 over 5 minus 5 times secant inverse of x over 5 plus c. There it is. I could cancel these 5s out right here. Okay, what do y'all think? Well, I didn't ask everyone to work the whole problem. I asked everyone to just at least fill out that first part, which I did not feel comfortable giving you all that part because I just didn't think we talked about it enough. So I thought the tangent squared would be an easier problem because it was a homework problem. Maybe I think too much. All right, so really now the rest of today, what we need to do is just kind of expose ourselves to a little more variety within these types of problems. Practice using making the correct substitution and working out what the derivative is, the square root, rewriting the integral. When we rewrite the integrals, we should expect a trig integral. That's what we should expect to see. You don't know what I mean by that? Like, that new integral should have trig stuff in it. Sine, cosine, tangent, secant, something like that. So let's do... See, did I work out one of those? I think I worked one of those out. I did A, right? Okay. Let's look at C. C looks pretty bad, doesn't it? Let me write it down, then I'll get it. I'll clear the board here. Now C is kind of a pretty big jump up as far as the level. Do y'all want to see an easier one before I do this one, or?
No, I just do this one.
Yes, you do want to see an easier one first? Yeah, B is easier. I didn't do B?
I don't think so. Yeah, I just have A.
Yeah, okay, I'll do B first. That all right with everyone? All right. Whoa. Now, on B, you might even recognize this. Do you recognize that? Look on your formula sheets. See if you have a formula that allows you to find the antiderivative of 1 over, I think on your formula sheets they're going to use u instead of x. So do you have something that says 1 over square root of u squared minus a squared? May I look? May I peek? No, you can flip through it. Is it 20? No, there's no root there, huh? X squared minus a squared. No.
Number 19.
No, that number 19 is not under a root. 16? Nope, that's backwards. So no, huh? Must be on the next page, which you don't have. It's okay, we can handle it. 16? Yeah, the variable in the formula there is u. And notice that they have the a squared minus u squared, which is not the same as u squared minus a squared.
But isn't it the same expression as we have in the bottom?
Yes, but okay, exactly. So we don't have a formula on our formula sheet where we would just do the problem without thinking, right? We have to do something for this. But this square root of x squared minus a squared matches exactly a trig substitution. So here I am thinking again. I think I'll think right here. What am I thinking? I'm thinking that this looks a whole lot like square root x squared minus a squared. Well, shit, it is exact. Ah!
can't see it.